Hello everyone. So again, welcome back to the latest lecture session. So in the last session, we have been looking at, or we looked at rather, various redox process or non-redox process in the context of chemical methods, right? As in, what are the various chemical methods that we can use to remediate a particular contaminated site. And in that context, obviously, we looked at a few examples, but one of the aspect upon which we spent more time, let's say, was in situ chemical oxidation, right? ISCO, I guess, right? So in that context, we are going to, we are going to have a particular case study, that's going to look at the application of these in situ chemical oxidation methods, let's say. And I chose this particular case study because it had, conceivable data available. As in, obviously, there are many such applications of cases where in situ chemical oxidation was carried out, but when I tried to find the relevant data, I couldn't find sufficient data or satisfactory amount of data, if I can say so, right? So and that's the reason we are going to choose this. So what's the topic, or what's the document that I chose, more or less? So it's the pilot scale development or demonstration, pardon me. Though I say that it's pilot scale demonstration, keep in mind that in situ chemical oxidation is widely used and widely practiced, let's say, right? But for that particular site, for some unique cases, they were looking at pilot scale demonstration, let's say, right? And based on that, they were planning to also use it at other locations, let's say, right? Again, though we are looking at pilot scale here, it doesn't mean that in situ chemical oxidation is at its initial or nascent stages, let's say, of development or usage, right? That's something to keep in mind. So we have this ISCO, and what is this we are trying to remediate? Let's say it seems chlorinated volatile organic compounds. So we have volatile organic compounds, let's say, right? So what's the particular document that I am looked at, or I came up with, or looked up rather, design and develop deployment guidelines, for this particular pilot study, let's say, right? And then developed by the National Risk Management Research Laboratory, let's say, right? And then we have the relevant authors. So you can obviously, if you want to, let's say, gather more information, look up the source document that's available online. So the data that I'm going to present over the next two sessions, let's say, is going to be from this particular publicly available document out there, right? Again, this is the source, and you can look at or refer to this particular source if you want more information now, right? So let's move on. Obviously, what are we looking at? We have a site contaminated with CVOCs, and we are looking at in situ chemical oxidation, let's say, to be able to remediate this particular site. First aspect, let's say, what are some of the issues that you would face now? If it's volatile organic carbon, let's say, right, firstly it's volatile, but I guess in this particular site they have not really looked at, let's say, remediating that particular gaseous phase, let's say, right. Typically they looked at remediating that particular VOC, which would be adsorbed onto the soil now, right? And again, when I say adsorbed onto soil, what part of soil, let's say, or what caused this particular sorption of the volatile organic compound onto soil? You have this organic matter, let's say, or organic fraction of the soil, and that acts as source, let's say, or media for adsorbing these particular volatile organic carbons. Again, that's what we are going to look at. So we have these VOCs, and by applying an oxidant, we are going to try to remediate the particular site, let's say, right? So let's look at that particular case. So location is again in South Carolina, right? And keep in mind that we are talking about a US Marine Corps recruit depot, let's say, as in when the people, let's say, in the US, let's say, again this is obviously from a site in the US, let's say, right? And here again, as I mentioned, it's in South Carolina, let's say, right? And here I guess this location serves as a base, let's say, for new recruits, let's say, to be trained and so on and so forth, let's say, and that's what we have out here. And what are the contaminants? It's perchloroethylene or tetrachloroethylene. So it has 4 Cl minus, let's say, right? And that's something we are going to look at, again also called as tetrachloroethylene. And typically, as we mentioned earlier, I believe we did look at this particular compound earlier too, I believe in the context of permeable reactive barriers, right? I think we did not start with perchloro or tetrachloro, but we started with trichloro, the compound which had 3 Cl minus, let's say, right? Again, here we are starting with the one that has 4 Cl minus, let's say, right? As in carbon, and then Cl, this is the structure. Again, typically toxicity due to these particular Cl, let's say, right? and typically if there are reducing conditions due to different pathways, either hydrogenolysis or cleavage of this particular Cl minus, let us say, right, you are going to have different pathways, and you can have what do we say, TCE, DCE, vinyl chloride. Again, vinyl chloride is pretty toxic, DC is also toxic. So, some of these byproducts which are formed when this particular PCE or tetrachloroethylene is degraded are also toxic. That is something I believe we looked at in the context of PRBs, right, or the permeable reactive barriers. Again, what is the typical use of these particular what do we say, chlorinated organics? They obviously solve as solvents, let us say, right, they are obviously serve as solvents, pardon me, right. So, typically here they have a huge dry cleaning unit, obviously, right, you have a huge base and you need to dry clean, let us say, or clean vast amounts of soiled clothes, right. So, they have a huge dry cleaning unit, there obviously are going to use chlorinated solvents, right, and I believe they were using tetrachloroethylene, let us say, or PCE, let us say, right. So, in that context again they were using this particular compound in dry cleaning operations, right. So, let us look at what else we have. So, here we are going to look at remediation by subsurface injection of permanganate, let us say, right. I believe we looked at permanganate, let us say, in the context of the in-situ chemical oxidation, let us say, right, different oxidants, we looked at ozone and so on and so forth. In that context we also looked at permanganate, let us say, right, a strong chemical oxidant now, right. So, and that is what they are trying to do, and we will look at that obviously. So, some of the relevant aspects are that they looked at nested micro wells, also conventional wells, and what did they monitor, let us say, obviously for perchloro or tetrachloroethylene, this particular compound, and also for the byproducts as in the decomposition products as in TCE, the trichloroethylene, dichloroethylene, both the two isomers I guess, right, DCE and TCE, pardon me, yes, cis I believe, right, DCE, dichloroethylene, and also vinyl chloride, right, as we talked about. And how are they formed? Again, you had, if you have reducing conditions, let us say, and you have an electron donor, let us say, this is the particular what do we say pathway, let us say. I believe I have the pathway, but that is something easy to deduce, let us say. And here we are collectively referring to all these compounds as the chlorinated VOCs, let us say, or the chlorinated volatile organic compounds. The reason being that most of these are toxic, so you can obviously look at all these compounds, or you would typically look at that compound which is more toxic, let us say, typically vinyl chloride. But here the way that they have gone about is that they looked at the total CVOCs. Total would obviously take into account all these relevant compounds here, right. So, that is what they have looked at. So, let us look at or understand the site location. Again, it is out here along the coast more or less, right, again in a sensitive location or sensitive zone, if I may say so, right. So, again along the coast of South Carolina, and keep in mind that it is 1 mile south of city of Port Royal, right, that is a major city, yes. And what does this particular location serve as? Let us say we need some background. It serves as reception and recruit training facility, as in you have new, or you have recruits, let us say, to the US Army I guess, or US Marine Corps, pardon me, right. And these recruits are typically hosted here, and they are talking about particular states that are east of the Mississippi River. All those particular states that are east of the Mississippi River, all the relevant recruits from those regions, let us say, are sent to this particular base, right. So, that is a considerable, or you can understand the size of the base, and obviously all the women that enlist nationwide, let us say, right. Again, why did we choose this data? Not because it is in the US or such though, but because this, for this particular site I had or was able to find relevant data online, let us say, right. So, that is one thing to keep in mind, and let us move on. So, we are now going to look at, let us say, how this particular contamination occurred, right, and what is the background. Again, why is that? Because there are obviously lessons to be learned in this context, let us say, or in this aspect in the Indian context, let us say, as in we have a lot of dry cleaning units out there, either in the unorganized sector or in the organized sector. But to my knowledge, these remarkably toxic compounds, let us say, are rarely, or not rarely, to my knowledge they are not treated, or no enforcement too, I guess. And you have more or less this particular chlorinated solvent being dumped into the relevant soil or the drains, let us say. And the drains, the status of our drains, let us say, or even the end product, let us say, again these are CVOCs, they are also volatile. So, typically they can seep into the soil, again I am talking about the Indian context here, or they can volcanize too, depending upon the relevant temperature and the relevant conditions, let us say, right. Again, that is something to keep in mind, and now keep that in mind and let us see what we have out here. So, looks like they were storing this TCE or PCE in one of the tanks that was overfilled, right, and thus there was spill obviously. So, unknown amount of PCE flowed into concrete catch basin, as in they had, what do we say, it is all built up area, right, and they had the dry clearing unit there, and one of these holding tanks for this what do we say, compound that is toxic, let us say, to humans again, right, but again as is used here, it is an industrial solvent too, right, that spilled over, right. And obviously then they also had, again, due to various reasons, the what do we say, PCE, let us say, that overflowed was not collected or was not treated, let us say, right, it was not one of their priorities. And obviously worst case scenario, you had heavy rainfall, and once you have heavy rainfall, you are going to have runoff, and this washed the contaminant into the surrounding soil. So, keep in mind that it contaminated the surrounding soil, and also obviously traveled along with or was transported by this runoff from the rainfall into the storm water drains, right. So, two key aspects, right. One was that it spilled over into the surrounding area and contaminated the soil, right, and also because of its transport into the stormwater drains, let us say, it was, and now the drain, stormwater drain obviously is carried over to different locations, let us say, and they analyzed later that some of these stormwater drains had considerable leaks, let us say, and also they were going beneath the water table at some locations. So, this led to considerable contamination. Again, we are going to look at those aspects, right. One, as we can see, is that soil is contaminated, and again, as hydrophobic compounds, we looked at it in the context of pump and treat and so on and so forth. Pumping them out and treating is not feasible because the compound is adsorbed on soil, that again acts as a reservoir of this particular compound, right. So, we know that just pumping and treating it out is not feasible though, right. Again, one particular aspect was the tanks being overfilled and then spill, and then heavy rainfall leading to relevant contamination, right. So, let us move on. So, again, obviously during operation, and this is something, as I mentioned, we need to keep in mind in our Indian context, let us say. So, different during different times or during operation, let us say, miscellaneous spills, let us say, also resulted in release of this particular what do we say now, compound into the sewer, sanitary sewer, let us say, not the stormwater sewer, but the general sanitary sewer, right. While operation, let us say, you are going to have some minor spills, but that particular spills or those spills should be mopped up and cleaned, because again these are remarkably toxic compounds, let us say, right. But what happened here is that they did not do that. But for this level of large scale facility, the considerable amounts of PCE were generated, and thus also, I guess, considerable amounts of spills. I guess this is a conclusion that I am drawing or assumption that I am making, right. But in the Indian context, keep in mind that we because of the amount of loads that come in, this is something that you would presume happens, as in spills occurring or even the PCE being dumped depending on the relevant conditions, let us see. So, one aspect as we looked at was spill, and the other aspect was that miscellaneous or minor spills during operation. So, obviously now it is located in and near the old dry cleaner facility, as in they learned the lessons and then demolished this and demolished this old dry cleaning facility later and constructed a new facility later. But obviously thus we have an old dry cleaning facility here, and as I mentioned earlier, the PCE leaked from the broken sewer pipe, let us say, as in here you have the PCE going into the sanitary sewer and this is broken, right. So, now you have contamination of that particular soil and maybe groundwater, right. So, at location of, what is the location, 50 to 75 yards, let us say, maybe 50 meters, let us say, right, around 50 meters. Source of contamination for southern plume, as in there are two plumes, as we are going to understand, let us say. So, we can visualize the two plumes, one due to the contamination from this sewer line, as in one plume is due to, let us say, the compound or contaminant being transported by the sewer line, and the other one due to the storm water drains, let us say, right. So, two plumes, two more or less corresponding to these two sources, let us say, right. And in early 2001, let us say, once they noticed that there is contamination and so on, what did they do? The main dry cleaning buildings, solvent tanks and other related structures were demolished and removed from the site. So, keep in mind that at least once they knew of this particular contamination of the soil or such reached the relevant higher authorities, they did start taking remedial steps or remedial action, let us say, and the contaminated soil at the original spill location was excavated. So what happens now at the original spill, when let us say they had this heavy rainfall, let us say some of this particular contaminant flowed into the surrounding soil, let us say, right. So this soil they excavated, let us say, and treated, let us say, and then interim remedial action was initiated, let us say, I mean minor caps and so on. But keep in mind that though they removed a particular fraction of the soil, let us say, or volume of the soil, pardon me, right, you still have, or you will have, what we say, seepage of this particular or transport of this particular compound into the subsurface, and then along with groundwater it will be transported, right. And again keep in mind some of the compound was also transported by the storm water drains and also the sewer drains or so on, right. So there are different aspects. So one aspect at least what they tried to address was immediately anyway was the source location, the contaminated soil that was excavated and I guess taken off site for treatment, right. So here let us look at the location of the storm and sanitary sewers, right, and this is the dry cleaning facility that we are referring to, let us say, yes, and these red dots or the red colored lines represent the sanitary sewers, okay, and the storm sewers by these green dotted lines or the solid lines, let us say, right. So I believe we will look at the legend again or legend in a few minutes, but these yellow colored parts of the storm water drain, again keep in mind this is a storm water drain, the one in the green color, but you have some parts of it colored in yellow. So these particular parts or in these particular parts the storm water drain is below the groundwater level, that is something to keep in mind, right, we will look at that later. So here is the legend. So storm water manhole or drain, that is the green color, let us say, right, and again sanitary sewer is the red colored one. So the key is to understand the flow of this particular sanitary sewer. So any contaminant from this particular location, let us say, that is collected out here will be taken in this direction, let us say, right. So if there are leaks in this direction, obviously you will have relevant contamination at that particular location, and this is the section of the stormwater sewer that is known to be or suspected to be below the water table, let us say, again 2-3 different aspects. So the other aspect is to understand the what is the direction of the stormwater drains too, or the flow of the water in the stormwater drains. Again keep this in mind because we are going to come back to this later. So now we are going to look at the distribution of PCE, let us say, in groundwater. They started taking samples. So obviously as you can see, once you contaminate the relevant site, let us say, you all need to obviously understand the site and the extent of contamination. So from this particular set of data, as you can see, considerable what we say number of locations were monitored, let us say, right. So here we have temporary wells in March 2008, June 2008, August 2007, June 2007 and so on. So over a period of a year, let us say, they looked at different aspects, right. And again what's our where is our dry cleaning unit, that is out here, yes. If you look at the plumes, let us say, as in this is these are the contours more or less, right. So what does this solid line indicate now? A line of equal tetrachloroethylene concentration in microgram per liter, let us say, right. So for example, all along this particular line the concentration of the relevant contaminant is 10 ppb, let us say, microgram per liter, and along this it is 100 and so on. So it gives you an idea about the source of your particular contaminant and the direction in which the contaminant is being transported. So here as you see is one source of location, and as you can see that is on one of these relevant storm water drains, right. So this particular one source, let us say, the northern plume is along the storm water drains. Again keep in mind that these green colored lines are the storm water drains. So you can now presume that or maybe presume that, I guess, right. The initial spill that occurred when there was a rainfall, let us say, and this spill was transported through the storm water drains, so ended up leaking into the relevant soil out here too, right. So that is one particular case, let us say, it looks like the source is somewhere out here. And as we looked at continuous what we say are miscellaneous spills, minor spills during the daily operation, let us say, they were going into the sanitary sewer, which is this particular red line, let us say, right, and that is being transported out here, and looks like here at this particular bend, let us say, or that particular joint, there seems to be a leakage, and as you can see here you have a source of almost 10,000 ppb, and then you see the different contours 1000, 100 and 10, right. So now you understand that the contaminant is being transported in this particular direction. Obviously, we also need to look at this particular data in the context of the groundwater data, right, as in the groundwater table, and understand in which direction the groundwater is moving. But looking at these contour lines, right, or understanding from these contour lines, you can see that you can just gauge the direction of movement of the relevant contaminant plume, let us say, right. So, that is something to keep in mind. So, site characterization, I guess a huge site, that is something to keep in mind, yes. But the major aspect is that if you remember, let us say it was along the coast or near the coast, pardon me, right. So, you have dry land, salt marshes, saltwater creeks and ponds, so it is an ecologically sensitive area, right. So, obviously, it is what do we say, something that is a priority. Again, as we know, once or if let us say this particular VOC or an NAPL, let us say, is transported over wider area, let us say, it obviously gets more difficult to remediate, and especially let us say in these ecologically sensitive areas, let us say where you have different or thriving ecosystems, let us say, the adverse effect or the potential endpoints, let us say, are going to be numerous now, right. So, that is one particular aspect to keep in mind. So, what is the feature that we have here? We have a shallow superficial aquifer which extends to up to 15 feet below the ground surface, let us say, right. So, if this is your subsurface, you have a shallow aquifer, let us say, that extends to 18 feet, pardon me. So, around 18 feet, let us say, right, that extends till 18 feet, and that I guess means we have an impermeable layer at around 18 feet from the surface, let us say, right. So, let us look at what else do we have, and this consists of fine to medium sand. So, what is the key aspect here? Typically medium sand, I guess we do not yet know how fine the sand is, but again typically let us say you would expect the permeability or the hydraulic conductivity to be high, right. So, the relevant transport of the contaminant, if any, will be considerably high, let us say, and also because it is sand, it will typically not have a lot of organic fraction, let us say organic content, pardon me, and thus let us say this particular VOC, let us say, could have permeated through, let us say, or been transported through to the greater depths, let us say. That is something to keep in mind. One, that permeability is typically high for sand, let us say, those kinds of layers, and also let us say because of typically lower organic fraction of carbon, let us say, the relevant contaminant would have not been adsorbed onto sand, but would have transported through it, or most of it anyway, right. So, let us look at the other aspects. So, there are some obviously localized silty and clayey layers, let us say, right, but they are limited in their relevant area, let us say, or their coverage. So, as in maybe out here, this is the side view obviously. So, let us say you have some minor clay layers and so on out here, right, and within this 18 feet, but they are limited in area, right, and thus they are not expected to be functional confining units. They will not act as confining either the aquifer or the relevant NAPL, let us say, right. So, as we mentioned or suspected earlier, a peat and silty clay layer occurs from 17 to 27 feet below the ground surface. So, from here to around 27 feet, right. So, maybe 10 more feet out here, right. What do you have? You have a clay layer, let us say. So, this serves as more or less what is its clay layer, right. So, it is going to have relatively less hydraulic conductivity, let us say, right, and thus let us say that is going to act as a confining layer, let us say, right. So, that is something to keep in mind, right. And what else? Effectively function as a local confining unit both for the water and for the NAPL, and the groundwater is 3 to 4 feet below the ground surface. That is a key aspect, as in the groundwater table is just or very high because it is obviously near the coast. The groundwater table is just 3 feet below the ground surface, let us say, right, or 1 meter deep, right. That is something to keep in mind. So, again keep in mind that this particular site was on the coast. So, you are going to have tides, right, tide coming in and going out. So, because of that particular tide, the groundwater what do we say, level fluctuates by 0.2 to 0.6 feet, let us say. That is something to keep in mind. Contaminated interval is shallow, let us say, okay. So, one advantage that they had at this particular site is that the contamination was typically, or at that particular point in time, was limited to the shallow regions, as in why is that advantageous, let us say, because then limited overburden pressure, right, leads to requirement for less injection pressure, as in here you need to inject your relevant compound, right. I believe they are looking at manganese, right, permanganate. And now let us say if you need to inject it to greater depths and there will be a greater overburden pressure, and if you want to let it transport, let us say laterally, you will obviously need to what do we say, inject it at higher pressure, but obviously you looks like here it is shallow, and thus the overburden pressure is not high, thus requiring less injection pressure. Let us say that is one particular aspect to keep in mind, right. So, let us look at the hydraulic conductivity here, right. This is on the x axis and this is the depth below the ground surface, let us say. So, as you see, they had particular, I mean initially for some reason, the hydraulic conductivity is less, let us say, in this particular region of around 1 meter, if I may say so, but in this particular region from 6 or 7 to 10 meters, the hydraulic conductivity is remarkably high. So, any contaminant, let us say, that is transported to this region, let us say my contamination occurred out here, and over time let us say it has reached this particular region, let us say, what will happen? Now, this contaminant is going to be transported over a wider area, let us say, or wider extent, let us say. Why is that? Obviously, as you can see, hydraulic conductivity is remarkably high at this particular depth. So, it is again decreases slightly, let us say, right, at the deeper locations maybe, but again it is still relatively high though, right, and at 16 or below 16 feet, as we looked at earlier, we have this impermeable layer, right. So, that is something to keep in mind, and let us look at it. So, they have two aquifer zones, they are classifying them as shallow and deep. Shallow, as we saw, let us say, hydraulic conductivity was typically high, almost 4 times higher than the one in the deep location, let us say, right. So, hydraulic gradient is also given here, again hydraulic gradient is also high. So, how do you calculate the Darcy's velocity now? Darcy's velocity gives you an idea about the groundwater flow velocity, right. So, it is Ki, right. So, as you can see, K is high and also the hydraulic gradient is also high, right. So, typically as we can see in this region, the contaminant will be transported over considerable or relatively greater distances, let us say, right. That is something to keep in mind. So, we also have now groundwater levels. Why do we need to understand this, let us say, right. We want to be able to understand, let us say, the groundwater levels, because we want to see in which direction is the groundwater flowing, let us say, or traveling, let us say, right. So, let us try to understand it. So, here is our particular dry cleaning unit, and here we have 3.4, 3.3, 3.2, 3.1, 3.0, 2.9, 2.8, so on and so forth. So, if you look at this particular level, you see the gradient, and now you will obviously, you can deduce that the groundwater flow is in this particular direction, let us say, right. So, that is what we have out here, right, groundwater flow direction, and again you have some localized patterns here, right. You have some localized patterns here, and that is what we have them represented here, right. So, why is this important? Again, if you keep in mind earlier, we had this particular sand receiver somewhere out here and going out this way, right. The green one is the storm sewer, this particular red colored line is for the sand receiver, let us say, and if you remember, there was a spill somewhere out here, or not spill, let us say leak from this particular sand receiver, and you saw that this particular plume was in this particular direction, or the contaminant was being transported in this particular direction, right. So, that is something to keep in mind. And also in the northern area too, there was some particular contamination here, and as you can see, the contaminant is again being transported in this direction. Why is that? Because it follows the path of the groundwater flow, right. So, that is something to keep in mind, as in we have two plumes due to two sources, one somewhere out here and one somewhere out here, let us say, right, one due to the sand receiver and one due to the storm water receiver, right. That is something to keep in mind. And what have we looked at? More or less the groundwater levels and so on. They looked at monitoring wells and so on, so I will skip this. So, what is the conceptual model for the CVOCs and aquifer core locations where they, what do we say, collected the samples now, right. What is the relevant conceptual model now? So, let us look at that particular aspect. So, initially they looked at this particular model, right, and keep in mind this is the dry cleaning unit again. So, they looked at the relevant measurements and saw that the major source is not only from that one time spill, though it was considerable, they were obviously able to excavate some of the soil and such, and though it was transported by stormwater drains to maybe a particular location out here, right, they saw that the major source was this particular point in the sanitary sewer. And how did that particular contamination occur, right, and why is that relevant to the Indian context? As I mentioned multiple times earlier, right, it is because of the daily spills, let us say. It is not the one time spill that affected or mattered a lot, it is that there were spills daily, and all those particular spills that occurred daily were washed through these sanitary sewers, which leak, let us say, at this location, and this is the plume that they assumed, I guess, right, and you know that the groundwater was flowing in this particular direction. And they looked at these transect locations where they took both the soil and ground, mostly the soil samples T0 to T6, and as you can see, to understand the relevant aspects, they have samples along the longitudinal direction and also in the lateral direction, as in A, B and C. So, B is along the center line of the plume, as you can see, more or less, right, and A and C on either side, so you can get the relevant idea about the diffusion or such too, right. So, here typically you have both advection and diffusion in this direction, right, in this direction, and typically I guess dispersion or diffusion in this particular direction, let us say, right. So, let us move on, and what else do we have here? I guess we have some control wells out here, right. Let us look at the legend. So, soil core transects, obviously the soil samples were taken at T0, 1, 2, 3 along these particular transects, and stormwater sewer, that is something that we looked at. So, different manholes. So, here they also looked at manholes and used them as sampling ports, let us say, right. Location of background cores, let us say, obviously outside this particular contaminant plume, as in why do we need to obviously look at these background cores, let us say, as in you want to understand the soil characteristics before it was contaminated, because once it is contaminated you are going to have different chemical reactions, chemical and maybe biological process too, that change the characteristics of the soil, let us say, right. So, you want to understand the background or the initial characteristics, and thus obviously you need that particular data, and that is what you have here. So, they have different permanent wells, let us say, and also location of the aquifer cores out here. They also have some permanent wells that they have drilled into, let us say, right. So, I guess you now get an idea about, or picture of the contamination and its relevant transport, let us say, and I guess I am running out of time. So, I will end this session today, let us say, or end this session for now, and then in the next session we are going to look at the relevant aspects, let us say, right, as in manganese, let us say, or permanganate, if added, what are the relevant byproducts, is the relevant contamination and also remediation occurring both at the shallow and the deep locations, and so on, and what are the relevant hurdles, let us say, right. I guess with that I will end today's session, and thank you.